So we started the recording. This is the worksheet solution class for the work energy power chapter, and we'll pick up problems and let's go ahead and try to solve this. বলো এখান থেকে তোমার কি কি পারো নাই, কোন কোনগুলা মিলে নাই বা কনফিউশন আছে। পেজ নাম্বার 42 আইদার বলো অথবা লিখো। Number 6, okay. Number 6 আমরা একটু খেয়াল করি। A crane moves its load. আচ্ছা, প্রবলেম গুলো অল মেসেজে লিখো যাতে করে সবাই বুঝতে পারে যে কোন প্রবলেমটা আলাপ হচ্ছে। ডোন্ট গিভ মি ইনডিরেক্ট মেসেজ প্লিজ, আই অ্যাপ্রিশিয়েট দিস। all problems are welcome, all problems are welcome, but preferably write it in all chat to everyone, not direct message. আচ্ছা বলতেছি আমি, I got a recommendation from for 6 and 8, so we'll go for that. Number 6 একটু খেয়াল করি। Number 6 বলছে a crane moves its load diagonally as shown, by which distance must the weight of the load be multiplied in order to find the increase in its gravitational potential energy of the load. Now what you need to understand that the gravitational potential energy of a certain object, oops, this is the last class. How do I get rid of this? I get rid of this, and okay, I can actually do Control A, delete. Beautiful. So let me just go all the way to the left. Okay, so and 100%. All right, the thing is the formula that gives us the calculation for expression for the GP calculated for a given scenario is given by GP equals to mgh. So if I write this, GPE equals to mgh. Now this h is always the vertical height, always, irrespective of the type of the object. It could be in a curve, it could be in a straight line, it could be in a circular or semicircular or half circular or like an arc. No matter what, it is always the vertical height from the starting position to the end position. So if the object somehow gets from a lower level to a higher level, whether it goes from here to here, it goes from here to like this here, or it goes like this here, doesn't matter. For all of these motions, the GP gained of the object is always the same. So if it goes up, GP is gained. If the object goes down from a higher level to a lower level, then the GP is lost. That's basically it. It's applicable for all the cases. So if you understand this part, now you should be able to understand answer this question much too easily. Which one do you think is the characteristics for the gravitational potential energy? I mean, by which distance should it be multiplied? I mean, oh, এখানে একটা জিনিস খেয়াল করে সেটা হচ্ছে mg মানে হচ্ছে weight. So I'm যদি weight into h করি, that is basically the same thing as mgh. So that they actually asked us that which of the distance should be used or should be multiplied with the weight to get the GP increase. So which one do you think can be correct answer? Vertical distance covered is which one? Hello. Someone respond? No response? Okay. B is the correct answer. I hope you understand that. If you don't, you can ask me. Okay, someone asked for question. Yeah, B is the correct response for this question. A has nothing to do. D is the diagonal distance. C is the horizontal কে যেন কথা বলতেছো, তোমার কথা কেটে আসতেছে, শোনা যাচ্ছে না। তুমি একটু কষ্ট করে যদি মোবাইল ডিভাইস ইউজ করো, ওয়াইফাই কাছে গিয়ে বসবা, তাহলে একটু ভালো হয়। কেউ যেন কথা বলতেছো, আমি বুঝতেছি না। অথবা কোশ্চেনটা চ্যাটে লিখো so that I can respond to it. If you have a look at question number 8, question number 8 is saying which energy changes take place when a pedaling cyclist uses a generator dynamo to light his bicycle lamp. Okay, now first thing first, you have to understand, whenever the bicyclist is pedaling, the initial form of energy is chemical energy, which is the stored energy within his muscles. So chemical energy is going to convert into bicycle's lamp. So let me just show you a single image for how a bicycle generator works. Let me just show you so that it is easier for you to understand. Bicycle generator images. So not these, Actually, this could also be an example, but I'm looking for the light creating bicycle image. Okay, these are the bicycle dynamos, which can be used to illuminate some light, front light or backlight, or charge some battery so that you can use the battery to illuminate the light. The idea is very simple. Have a look. This is what we call a gear. It is actually pressed against this rubber tire, and whenever the cycle wheel is gonna rotate, this thing will be rotating as well. So a portion of the cycle's energy or the chemical energy coming from the cyclist will have to be used to run this generator. This generator produces some generator, and eventually it goes through these wires, and eventually the light bulb can be illuminated. This is a very simple scenario for the bicycle dynamo that we talk about. With appropriate things, with appropriate design, appropriate electronics, you can also use it to charge up your cell phone devices. For example, one of the examples are over here. Or you can use it to give some blinking lights for safety, and so on and so forth. So in this case, it says that which energy change take place when a pedaling cyclist uses generator/dynamo to light his bicycle lamp. So the first form of energy is chemical, then it converts into kinetic. The kinetic energy runs the generator, and then the generator converts into electric, and from the electric it converts to light and heat both. So we have to look in this scenario that which of the sequential term is the most appropriate. If you look over here, chemical into kinetic into electrical into light, this one sounds really logical. This one looks like to be the correct answer. However, it would have been better if they gave us light plus heat. Since they didn't give heat in any of the options, so let's forget about the heat part. A is supposed to be the correct answer. Rest of the answers are not true because none of the other answers start from chemical. But the first form of energy available for this system was chemical energy stored in the muscles of the bicyclist. So A is the correct response. Anything else from this page, anyone? No. Page number 43. Anything from page number 43? 13, 18. Okay, let's go for these two. And if any of you else add more problems, we'll pick them up. No big deal. Have a look at 13. Acha, one of you kids actually asked me a question in my direct message that you made some device in your school project that you think defied the conservation of energy law. Who messaged that? I forgot the name, but I would like to discuss that in today's class. এই মেসেজটা কে দিছিল জানো? If you want to keep it a secret, you can write me in direct message, sir, I did. Then we can keep you anonymous if you don't want to be expressed. So feel free to do that. Have a look at number 13. In a hydraulic power station, water from a reservoir falls down a long pipe before entering the turbines. The turbines then run the generator. What is the overall energy conversion? Now, this is the key term, overall. Overall or total means from the very first form to the very last form. So the very first form of the energy is exclusively for the hydraulic power plant. The initial form of energy is the GP stored in the water. So the total, the detailed form of the energy conversion is there is GP stored in the water. It falls down through a pipe. So GP converts into K. Then K rotates the turbine. So K still remains K, but it simply gets transferred from the flowing water into the rotating turbine. And then the turbine operates a generator where the K converts into electrical energy. So if you think about overall energy, it is the GP stored in the water converting into electrical energy out of the generator. So have a look. Which one is the correct response? I think D is the correct response. The keyword is overall. Overall means the very first form and the very last form. All the in-between forms are not discussed over here. Have a look at number 18. Question number 18 says, a ball is held at rest on one side of a curved track. The ball is released. It rolls down to one side of the track and part of the way up the other side. The height of the stopping point is less than that of the starting point. What is the sequence of energy changes between the starting and the stopping for the first time? I would like to take this question out because I'd like to discuss this in a bit more detailed version. Oops, this is so small. Oh, we can make it big. Whiteboard is much more better than paint. I didn't know that. I started using whiteboard very recently, and honestly speaking, enjoying it a lot. Okay, try to understand. If we have a look over here, that the ball started over here, essentially the ball has some GP. Whenever we release the ball is going to start from zero velocity with some significant amount of GP. The ball is going to roll all the way down, and eventually it's going to rise up to here. Rise up to here means at this point, once again, the velocity of the object is zero. So starting velocity is zero. Here, the final velocity is also zero. So the question says that what is the sequence of energy changes, which means we have to talk about all the in between energy form that is relevant here. So as the ball is gonna fall down, you do understand that from this height to the very lowest point, we're definitely gonna have a GP plus K, GP converting into K. And as the ball rises from this lowest point all the way to a higher height, K is gonna converting to GP. I have a reason not to write this in the same arrowhead. I'm gonna say that in a bit. So these are the two primary energy conversion that we already understand. But one thing you have to consider, you can see that the starting point is significantly higher compared to the stopping point, which means within the process of running through this entire track, the ball actually lost this much height worth of GP. This much height worth of GP. This much height worth of GP means you can calculate how much energy was lost in terms of GP if you know the two height of these two things, and if you use this difference of the height, or I can write that energy loss for this much motion can be given by delta GP, the difference of the 2 points GP, which can be also calculated as mg into delta h, where this if we represent this height loss as delta h. Now, why did this energy go? This energy is logically being wasted from the system, and wasted energy usually always go out because of friction, some sort of friction, and that friction converts the energy into heat. So considering that the ball is going through a curved track, the physical friction or the friction between the ball and the track is supposed to be significantly larger compared to the air resistance. To be honest, air resistance can be also considered to be a sort of a friction, which is can be called a fluid friction, because the air actually provides some sort of obstruction in the path of moving objects. So in that sense, we can say that as the ball falls down, GP converts to K and also produces some heat. Whenever this heat that is produced will be dissipated to the surrounding. It is not stored within the ball, or it can be stored in the ball, or it will be stored within as heat energy, but not kinetic energy or not gravitational potential energy. Then as the ball rises up this is applicable for this part, and then as the ball rises up for this much segment, that K will be converted to GP, but not all of it. In the same process, as the ball rises up, out of the total K that we had available over here, some K would be converted into heat energy as well. So this is a total energy conversion. So GP converts to K plus heat, and then the stored K also converts to GP plus heat. So let's have a look over here that which one seems like a correct answer. Potential energy into kinetic energy plus aero potential energy plus heat. So what they're proposing over here, that heat will be only be produced in the rising part, not for the falling part, because within the falling part we don't have kinetic energy plus heat. So this is not essentially appropriate. B number says potential energy converts into kinetic energy, which altogether converts into heat, and then the heat converts into potential energy. This is not correct also. The kinetic energy of the ball does not convert into heat altogether. A portion of the GP converts into kinetic energy and heat simultaneously. So these two are being produced together simultaneously. It's not that one gets produced first and then all of that converts into something else. No. So B also is not correct. Number C says potential energy converts into heat energy, which converts into kinetic energy and potential energy. It is obviously not correct. D says potential energy goes into kinetic energy plus heat, which also converts into potential energy plus heat. So this is actually, in my opinion, the best option that we have. It would have been better. It would have been better if this much part, can I select this? If this much part, why can't I? Achha, it would have been better if the heat was kept alone and this potential energy plus heat would be given an arrow like this, because this heat that is produced doesn't get converted into any potential energy. This heat simply remains as heat and gets stored within the object and eventually gets dissipated into the surroundings. So that's that. Ishak, yes, whatever you write is correct, but only for the case of gaining height. What Ishak asked a question that if velocity decreases, k reverts back to gp. This is the appropriate explanation for this question, but not for all question. There can be scenarios where an object is going in a straight line and it simply slows down due to friction and eventually comes to stop. Here is a flat line, so there is no gp again. Here all the k is converting into heat energy due to friction, so here is no gp conversion. Gp conversion will be only available whenever the object goes from a lower level into a higher level. বুঝছো কি বলছি? I think so. আচ্ছা, এই পেজে আমাদের আর কোনো প্রবলেম নাই. Let's go for page number 44. You have any question about 44? MCQ paper, page number 44. Question number 30. Okay, let's try this, and if we have more, we can go forward for more. Question says this one. Let's take this out. We have more space over here. How big is this space? Okay, pretty big. Oh, there is no practical end to this thing. Never mind. This whiteboard can be as big as I want it to be. Okay. So I'm just gonna place it down right over here. Then zoom in and yes, keep it 100% and make it this one bigger. Okay. So a person exerts a horizontal force of 500 Newton on a box, which also experiences a friction force of 100 Newton. How much work is done against friction when the box moves a horizontal distance 3 meters? Interesting question. Let me make this make sense to you. What I need you to understand, I mean, hear me out. Initially, let's say the box was right over here, and that the box moved from here all the way up to here. They actually showed only one box to avoid confusion. Now, the person is pushing the block by 500 Newton. It covered a distance of 3 meters. So work done by person is equal to 500 into 3, 1500 joule. What would be the actual work done or net work done on the object? Or if we to get that, I can, if I write that net work done on box would be the resultant force into distance covered. In this case, the resultant force should be 500 minus 100 because frictional force 100 Newton is working in the back or reverse direction. So that would be 400 multiplied by 3 gives you 1200 joule. And if you do the subtraction, that basically gives you the work done against friction or energy loss due to friction. Work done against friction is basically another way of saying energy loss due to friction. That would be 300 joule. That's as simple as that. This one is understandable. It should be. Or other way you can say that frictional loss can also be calculated directly. Frictional loss equals to friction force multiplied by distance covered. Now, if you wonder, sir, why does this work? This works because the friction is always working in the reverse direction. That's because of this reverse direction, we have used the term loss. If it was not working in the opposite direction, we would have gained net work done or positive work done. So here the friction is doing negative work, or in other words, you can say that it is actually taking out energy from the system. It is taking energy out of the system. So that is friction force is 100 Newton multiplied by the distance covered, that is 3 meters. So you have 300 joule is the loss due to friction. So correct answer is A. বুঝতে পারছি? I think so. Anyone, anything else from this page? No. Page number 45. $37. That's a long 37. Anyway, works for me. Okay, we'll have a look at 37. Hello. কে জানো কি বলছে আমি বুঝি নাই। Was that zigzag noise only for me, or rest of you also heard the zigzag noise? বলুন তোমরা কি আজকে কেউ কথা বলবো না?
স্যার
বলো।
আপনি 39 নাম্বারটা বুঝাবেন?
হ্যাঁ বুঝাবো, সমস্যা নাই।
ঠিক আছে।
এখানে লিখলেই হবে যে জুমের চ্যাটটাতে নাম্বার লেখো, নাম্বার এখানে ড্রপ করলেই হবে, নাথিং এলস। ওকে, I'll explain this, no big deal. আচ্ছা 37 টাকে দেখি, তারপর 39 বলতেছে। 37টা দেখি। A mass hangs on a string fixed at point P. It starts from position 1 and swings to the furthest position on the opposite side. It then oscillates several times with decreasing amplitude before ending at position 3. Okay, first thing first, what we need to understand, do you understand what we mean by the term amplitude? Amplitude termটার সাথে কি আমরা পরিচিত কিনা? What do you mean by amplitude? Let me first. Yes. Let me just explain what does the amplitude means. Whenever any object undergoes periodic motion. Periodic motion means it comes to the same position after a same time. A circular motion can be a periodic motion, but a circular motion doesn't have amplitude. Amplitude is applicable for objects motion, which is periodic, preferably, and also back and forth or to and fro. So that can be in a straight line. That can also be in some sort of a curve. For this example, the object was going in curve. So the question actually gives us a situation like this. So it says that the object starts from here. After one swing, it reaches up over here, and obviously after that the object is going to go back. But it says that after several of these swings, the object finally comes to a stop at this position. And the term amplitude means whenever any object undergoes oscillation. Let's say if I show you a linearly moving object, for example, if I give a physical setup, let's say we have a wall over here and we have a table over here, we have attached a spring over here, and with the spring we have attached object over here, and consider the surface frictionless. So this is what we define as the equilibrium position of the object. If we now pull the object over here by a distance of, let's say, s, and release it, the object is simply gonna come back to this position, and which is gonna bounce back to the other side. It's gonna keep on bouncing. If this object doesn't undergo any losses, or if the surface is perfectly frictionless and there is no air resistance as well, and the spring material doesn't heat up over time, this oscillation is supposed to go on forever. But that is not a practical scenario. We always have some friction on the surfaces. Air is also a problem that we always have unless we make it vacuum. And also, if we even can prevent these two things altogether, even if we can, which is quite unlikely, whenever we squeeze and expand an object, the spring materials undergoing squash and expansion with the oscillation, they are going to produce some heat within themselves because of molecular gap will be changing. So that comes out as a heat energy from the object. So this object will definitely come to a stop no matter how long it takes for a practical scenario, no matter how well this design is. The amplitude is said to be the maximum displacement that an object does from its equilibrium position in one direction. So if I consider from left to right, the maximum displacement, it can be said to be amplitude. It can be this one or it can also be this one, but not the sum of these. I said that the definition again. Amplitude is defined as the maximum displacement, which is a vector quantity. The amplitude is defined as the maximum displacement any object moves from its equilibrium direction or equilibrium position in one direction, so on one side. So what they're saying that whenever we release the object, it started with a pretty large gap, but whenever it came up over here, you can very well see that this angle is smaller than this one. You can also see it in the figure as well. If you have a look at the figure, you can see that this angle is significantly bigger compared to this one, which means this object, hello, I suddenly have a notification saying internet connection unstable. What is this? Hello.
জি স্যার শুনছি।
আচ্ছা, okay. So it means that as the object traveled from this position to this position, we had some loss of energy, and then the object is going to come back from here to here. It's going to have some more energy, loss of energy. So slowly but surely the object is going to have less amplitude. It will be able to move less and less and less, and ultimately the object will come to stop. So the idea is very simple. Whenever the object comes from here to here, it would have converted its energy into K. And when the object will rise up, once again, it will have converted the K into GP. But in this entire process, some heat energy will be lost for both of these segments. এখান থেকে নামার সময় কিছু হিট লস হবে, এখানে উড়ার সময় কিছু হিট লস হবে, এন্ড আবার এখান থেকে যখন নামবে আবার কিছু হিট লস হবে, এখানে যখন উঠবে আবার কিছু হিট লস হবে। সো এই হিট লস হইতে 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 এক সময় পুরো ইনিশিয়াল জিপিটাই খরচ হয়ে যাবে, এন্ড আলটিমেটলি দ্য অবজেক্ট কামস টু রেস্ট। সো if you understand this concept properly, now you tell me which of this answer can be correct. The question says, where does the ball have the most kinetic energy? The highest value of kinetic energy will be available for which point of the which point of motion for the ball among the four options that we have. At A, it says at the position 1, which is wrong, because at A we only have GP. B says at position 2, which is wrong, because at B the object is also at rest. It is the farthest it could move from going from A1 to 2. So at B it only has GP. It's not moving, so it doesn't have any K. In C, it says the first time it at position 3. First time at position 3 happens to be the correct answer. Because as the object moves from point 1 to point 3, it would have moved through that one segment of dropping, and you will have some K plus heat generated. And that's your maximum K that you can get. As the object is going to keep on rising, it's going to keep losing more heat energy. So whenever it will reach to 2, it will definitely have less kinetic energy than before. And as the object comes back to the 2 to 3 position once again, it will be losing more energy. So it will have even less kinetic energy. So the maximum kinetic energy is possible when, for the first time, all the GP has converted to Ke, and we have the least amount of heat loss for the least amount of movement, which means the first time it starts from position 1 and eventually reaches to position 3. That is the correct response, which means D is the correct response. C is the correct response. বুঝে গেছে কি?
জি স্যার, বুঝে গেছে।
আচ্ছা, আমরা 39 নাম্বারটা দেখি। কেউ কি 30 বলছিলা? আচ্ছা, 39টা দেখি। কোশ্চেন 39 বলছে ইয়ং চাইল্ড। আচ্ছা বলো, আমি যখন কোশ্চেন পড়তেছি তখন তোমাদের এই স্ক্রিন থেকে না দেখলেও হবে, তোমাদের কাছে বুকলেট আছে, তোমার বুকলেট থেকে দেখলেও হবে, সমস্যা নেই। বিকজ আই বিলিভ মেনি অফ ইউ আর ডুইং ইউর ক্লাস ইন ট্যাবস অর মোবাইল ডিভাইসেস। রিডিং দিস কোশ্চেন ফ্রম দ্য mobile device can prove to be quite challenging because I'm not expanding it, zooming it all the way on the screen. So you can also read the question from the question paper booklet. That I think that would be easier. All right, question number 39 says, as a young child holds a ball over the edge of a balcony, the ball has gravitational potential energy. The ball is then released. It falls onto a concrete path below and bounces back up. Which sequence represents in the correct order the transformation of the gravitational potential energy after the ball is released? After the ball is released. So the moment the ball is released, at that moment all the energy is GP. You see that all the options over here are starting from arrowheads, which means before this arrowhead we had GP common for everyone. So they prefer not to write the GP for all the options. So they start with the arrowhead. So when the ball is going to fall from the person's hand, GP will convert into K plus heat because of air resistance, of course. When the ball is going to touch the ground and start itself getting squashed, then the K would be converting to EP. EP means elastic potential energy, but that is also one type of potential energy. So as the ball gets squashed, K converts to EP. Once after the maximum compression, the ball will start to expand. When the ball will start to expand, then the stored EP will once again start to come out as K, because when the ball gets squashed, it comes to a momentarily stop position and then it shoots itself at a very high speed upwards. I'm talking about bounces. So in the process of squashing, K converts to EP, elastic potential energy. In the process of expansion, that EP converts into K once again. So as the ball leaves from the ground once again, it will have some K within itself. Within this entire process, we'll have energy losses. We'll have energy losses due to heat. When the ball falls from the person's hand, right from here to the ground, we'll have energy loss due to air resistance. When the ball undergoes squashing and expansion, the ball undergoes but the ball produces heat energy because when materials are getting squashed. And then as the ball is going to start bouncing upwards, in that case, that kinetic energy that it gained from the bounce will once again start getting converted into gravitational potential energy, which is also one type of energy, potential energy. So if I go for this answer once again, have a look. I will paste it here. Where is the paste button? This is the paste button. Oh yes. Okay, so what we need to understand that for this scenario, from yes, there is my pen. From here to here, we are going to have GP to K. Then as the ball gets squashed, K into EP. As the ball expands, EP into K. As the ball starts to go up, K into GP. So এখন আমরা এখানে দেখি যে আমাদের এখানে কারেক্ট আনসার কোনটা হবে। হ্যাভ লো
স্যার এটা অ্যানসার সি হবে না? হ্যাঁ স্যার।
ইয়েস মার্কস কি ভুল দেওয়া? এটা মার্কস কি আনসার
স্যার
সি দাও না? সি
সি সি দেওয়া সি।
সি কারেক্ট আনসার। But I would appreciate, since I would appreciate, but CIP doesn't care about people's appreciation anyway. So the question actually says it falls onto a concrete path below and bounces back up. Bounces back up means we are basically talking about that the ball actually bounced back up. So I would say that after this, I would be comfortable. I would be more comfortable if they put, after Carnegie, if they put another potential energy. This would actually be much more comfortable for me, because bouncing back up means it has bounced off from the ground already. বুঝছো কি বলছি? বুঝা গেছে কিনা?
জি স্যার বুঝছি।
এরপর দিস হচ্ছে 43
তারপরে আরেকটা চ্যাটে পাঠিয়েছি।
43 হ্যাঁ 43 দেখতেছি। মানে কোন চ্যাটে? মেসেঞ্জার চ্যাটে? না মেসেঞ্জার কোনো মেসেজ আসে না। ওকে বাদ। সো আমরা দেখি যেটার নাম কি 43 নাম্বার দেখি। 43 নাম্বার কোশ্চেন বলছে the graph shows how the height above the ground of a bouncing ball changes with time. Height versus time. Which statement explains why the height of each peak decreases with time? Acha, try to understand what is the peak over here. This peak actually means that what is the maximum height of the object. One thing that you need to understand that নিচে নামাতে গেলে আমি খালি দেখা যায় যে মাউসের মতো মাউসের বটম হুইল প্রেস করে ফেলি। All right, what I want you to understand that within this question, this is the height of the object, and the graph is going on the right because this is the plotting of height versus time. So at this time t equals to 0, the object has this height. As time goes by, the object height decreases, and this is the point where it hits the ground, and then it rises up and then it hits the ground. The ball is actually not moving like this. The ball is not undergoing a curve motion. The ball is still moving up and down. That is the motion of the ball. But whenever you plot the position of the ball for every single time instances, this is the type of a graph of height versus time that you come up with. Now the question says that explain why the height of each peak decreases with time. The peak actually represents the maximum GP of the ball at that position. The reason the GP is decreasing is because for every single bounce, you're going to be losing some energy in terms of heat and sound to the surrounding. So energy will be leaving from the object for every single time it bounces with the ground. So let's have a look at the question. A says kinetic energy is converted into potential energy at each bounce. Kinetic energy, this kinetic energy converts to potential energy at each bounce. Well, this is half true. In the bounce process, we have both. For the squashing, K converts to potential, and for the expanding, potential converts to K. So this is not essentially untrue, but this is not essentially the correct answer, because the question asks us that which statement explains why the height of the peak decreases. This is a correct information, but doesn't explain why the height is decreasing. In B, it says kinetic energy is converted to thermal energy at each bounce. Now, this might actually be correct. This might actually be correct because it mentions about the thermal energy, which is basically a loss. But the reason I'm saying that this one might be correct because it says the kinetic energy is converted to thermal energy at each bounce. This can ambiguously mean that in each bounce, all of the kinetic energy converts into heat energy, but that's not the case. A fraction of the kinetic energy converts into heat energy. But so this is also can be considered to be correct to explain our question. But let's have a look at the other questions to figure out whether we can find a better one. In C, it says the ball gains energy on impact with the floor. This is absolutely untrue. The ball does not gain any net energy when it impacts with the floor. It simply converts its energy from one form into another form. Indeed, says the ball is wearing out. This has nothing to do with wearing of the ball. So I would say the correct response, if I was answering this, would be B. B makes most sense for what the question asks from us. বুঝা যাচ্ছে? hope so. Anything else from page number 46 or 47?
Sir, 53.
53. A tennis ball is dropped onto a horizontal surface. The ball bounces up and down. The height of each bounce gradually decreases. During the motion of the ball, what happens? পরে দেখো কি কি বলছে। The current energy of the ball is constant. Can it be constant while it is going up and down? Never. The potential energy of the ball is constant. Also not true. As high the object is, it has more potential energy and less K. The lower it is, it has more K and less GP. The sum of the kinetic energy and potential energies of the ball is constant. Well, this could have been correct unless they mentioned as this sentence. Have a look. In the second sentence, it says, as the ball bounces up and down, the height of each bounce gradually decreases, which means from the GP plus K or GPK amount, some amount of energy is always leaving, which means the sum of K plus potential energies is not a constant. It is slowly converting into heat energy over every bounce. So this amount sum is actually not remaining constant. So C is not correct. This is the total energy of the ball, ground, and air is constant. Now, this one might seem to be a bit complicated, but let me explain this. When the ball is going to undergo vibration, you have to consider that there is a system. System means consider a part of the world that we want to observe minutely. Within the system, we have the ball, we have the ground, and we also have the atmosphere. As the ball is going to bounce up and down, it's going to produce heat. That heat will be primarily stored or primarily primarily owned by the ball when it and also the ground, a small layer of ground where the ball actually does the collision. So the ground also undergoes a little bit of compression. The ball also undergoes a compression and expansion process. So both of these two things will become warmed up, but ultimately this heat would be dissipated into the air. So these are the three things within which the energy exchange is happening from the ball to the ground, and from both ball and ground, energy can be directly go to the air as well. Ultimately, it will be absorbed all the way by the surrounding, which means these three things are doing the energy exchange. So the total sum of all of the energy all the energy stored within this three object would be same. What I want you to understand that whenever the ball is going to fall for the first time, it would have most of the energy within itself. But after the first bounce, let's say the object comes over here. So this much portion worth of GP got out as heat energy. And after the second bounce, let's say the ball rises up to here. So this much height worth of GP got converted to got transferred to the atmosphere and the ground. So this is the answer that is correct in terms of the conservation law of energy. That the total sum of all the energies, including all the objects where the energy is flowing in or flowing out, all the energies which are actually exchanging the energy amount, the total sum of energy of all of these things would be essentially zero na constant. বুঝতে পারছি?
জি স্যার, বুঝছি।
Okay. Page number 47, anyone? No. Okay, let's go for the paper 2 and let's see if we can nail some problems here. Did we discuss?
স্যার, আপনি কি হচ্ছে গিয়ে এই প্রেসার চ্যাপ্টারটা শেষ করে তারপর পরীক্ষা নেবেন?
That is a very highly likely scenario, কারণ তোমাদের পরীক্ষার জন্য আমি এখনো কোনো প্রিপারেশন নিই নাই। আমি এই যে মকের জন্য ফুল ডাটাবেস বানাই দিয়েছি। ডাটাবেস বানানো শেষ হলে তারপর যারা এবার ওলেবেস দিবে, ওলেবেস একটু দিবে, এদের মকের কপিগুলো ডিস্ট্রিবিউশন শুরু করবো, তারপরে তোমাদের টেস্ট নেওয়া শুরু করবো। তোমরা হচ্ছে সবার শেষে। তোমাদের প্রেফারেন্স অবশ্যই আমার কাছে আছে, বাট যেহেতু আন্ডা বাচ্চা, ওই জন্য তোমাদের প্রেশার কম।
তাহলে স্যার আপনি বলছেন না সেকেন্ড বুকলেট দিবেন?
হ্যাঁ, আমাদের যখন ডেনসিটি প্রেশার পড়ানো শেষ হয়ে যাবে, তখন আমি তোমাদের সেকেন্ড বুকলেট দিয়ে সেকেন্ড বুকলেট পড়ানো শুরু করে দিব। তার হয়তো কিছুদিন পরে আমি এটা টেস্টগুলো নেওয়া শুরু করবো। টেস্টগুলো নেওয়ার আগে এগুলো আমি আবার রিভাইজ করাবো না। তোমরা তোমাদের আগে প্রিপারেশনের উপর লেকচার, ইউটিউব ভিডিও দেখে যা পারো পরীক্ষা দিবা। ওই পরীক্ষাগুলো আমি আবার সলিউশন ক্লাস নিব, তখন তোমাদের আবার একটু রিভাইজ হবে। বুঝছো কি বলছি?
জি স্যার, বুঝছি। থ্যাংক ইউ স্যার।
নো প্রবলেম। মিফতাহ, তুমি তো 53 লিখছিলা, 53 বুঝাইছিলাম? I think so. আচ্ছা, মেবি। সো এখান থেকে তোমরা কি পারো না? আমরা কি এই ওয়ার্কশিটটা করছিলাম? আমার কাছে কেন মনে হচ্ছে আমরা সেটা আলাপ করছিলাম।
স্যার 5 নাম্বারটা একটু বুঝালে ভালো হতো।
5 নাম্বার, আচ্ছা 5 নাম্বার বুঝাবো, সমস্যা নাই। আচ্ছা, তোমরা কি এটা এই বছর কেউ করছো, মানে লাইক স্কুলের পরীক্ষার জন্য বা হচ্ছে অন্য কোনো কারণে, মানে উইদিন দ্য গ্যাপ দ্যাট দ্য ক্লাসেস আর নট হ্যাপেনিং?
জি স্যার করছি, আপনার
যা
সবগুলোই করেছি, প্রেশারও করেছি।
আচ্ছা, তাহলে তো খুব ভালো, আলহামদুলিল্লাহ, কংগ্রেচুলেশনস, থ্যাংক ইউ। সো আমি এখান থেকে প্রবলেম দেখা দিয়েছি, তোমাদের যার যার প্রবলেম আছে এখান থেকে জিজ্ঞেস করতে পারো, অথবা ওয়ার্ক এনার্জি পাওয়ার চ্যাপ্টার রিলেটেড অন্য কোনো ইয়ার কোশ্চেনের যদি প্রবলেম থাকে, লেটস সে মনে করো তুমি একটা স্কুলে পরীক্ষা দিছো, ওখান থেকে একটা কপি দিছে, ওয়ার্ক এনার্জি পাওয়ার চ্যাপ্টারের পরীক্ষা দিছিলা, ওখানে একটা প্রবলেম তুমি পারো নাই, হেল্প দরকার, ওইটাও তুমি আমাকে ছবি তুলে মেসেঞ্জে পাঠালে আমি ডিসকাস করে দিব, কোনো প্রবলেম নাই। অথবা যদি এখানে মনে করো বার্ষিক কম্পালেশন আছে 2013 পর্যন্ত, 2013 এর পরে যে কোশ্চেনগুলো সেগুলো থেকে যদি তুমি কিছু অ্যাটেম্প করে থাকো অন ইউর ওন ফর স্কুল প্রিপারেশন অর ফর জাস্ট বিকজ ইউ ওয়ান্টেড টু, ওখান থেকে কোনো প্রবলেম দেখালে আমি হেল্প করে দেবো। বাট একটা জিনিস হচ্ছে যে ইফ ইউ ওয়ান্ট হেল্প ফ্রম ম্যাটেরিয়াল for material that is outside the worksheet, I always appreciate either if it is not a year question. Year questions are very easy to access in the PDF format because anybody can download them. It's available. But if you have some other resources like Red Spot or like school exam, or if you go to another physics teacher and you appear some exam over there and you would like to me to explain this thing, you take a snapshot of this picture, take a focused image of this picture and share it on the messenger group so that you can pick it up.
স্যার আপনার হচ্ছে গিয়ে ছবি কি আপনার পার্সোনালটাতে
না না না
পাঠাবো?
না 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 না, গ্রুপ ডিসকাশনে সব জিনিসপত্র মেসেঞ্জার ডিরেক্টলি পাঠাবা।
ঠিক আছে স্যার, যদি যে কোনো প্রবলেম হয়।
যে কোনো প্রবলেম হয়, বাট রিলেভেন্ট চ্যাপ্টার, ফর এক্সাম্পল মনে করো এখন আমি তোমাদেরকে হিট পড়াই নাই, আর তুমি আমাকে যদি হিট চ্যাপ্টারের প্রবলেম দাও, এটা বুঝাতে গেলে তাহলে আমাকে ইন
হ্যাঁ
মাই হেড
বুঝছি স্যার।
মানে যতটুকু পড়াইছে ওইটুকুর মধ্যে।
ঠিক আছে স্যার। স্যার আমার হচ্ছে গিয়ে একটু প্রবলেম হতে পারে, কারণ আমি একটু দেশে এসেছি। আপনি একটু আম্মুর সাথে একটু কথা বলিয়েন একটু।
তুমি আগে কইছিলে।
ক্লাসের ক্লাসের পরে আম্মু একটু ফোন দিবে আপনাকে।
আচ্ছা, আমার 7:30টার ক্লাস, তোমাদের ক্লাস তো 7:30টায় শেষ, 7:30টার পর আমার আবার ওলেভেলসদের ক্লাস আছে, আর ওদের এখন সামনে মক, ওই জন্য আমি ওদেরকে পার্সোনাল প্রবলেম সলভ দিচ্ছি। আমাকে কল ভালো হয় 9:45 দিলে।
ঠিক আছে স্যার, 9:45 দিব।
লেটস লুক এট কোশ্চেন নাম্বার 5। বাকিরা তোমরা কেউ কোনো রেসপন্ড করতেছো না, সো I hope that you are here. I believe that you are here and you are listening to the problem solving, but if you have any question tell me. আচ্ছা, মুস্তাফা, তুমি এখনো তোমার রোল নাম্বার পাও নাই। মুস্তাফা না, এটা কে, নাম কি? মোহাম্মদ মুস্তাফা ইসলাম। আচ্ছা মুস্তাফা ইসলাম, তোমাকে আমি রোল নাম্বার দিব। আমি যে মাঝখানে বিশাল অ্যামাউন্টে ডিসকাউন্টেড হয়ে গেছিলাম, ওখানে তখন আমার অ্যাডমিনিস্ট্রেটিভ পুরো ভেঙে পড়ছে। আই এম রিবিল্ডিং ইট বিকজ মক্স আর গেটিং স্টার্টেড অ্যান্ড বাসা চেঞ্জ করার পর কিছুটা অর্গানাইজ হয়েছি। সো তোমার রোল নাম্বার দিব, ডোন্ট বি ওয়ারিড। Thanks for understanding. Okay, question 5 says figure 3.1 shows a small hydroelectric system that generates electricity from moving water. So you can say we have a pipe, water coming out, and there is a turbine blade with 4 blades over here, and then this is starting a generator. Pretty simple stuff. Every minute, important information. এই যে একটা জিনিস খেয়াল করো, in any case, if you come across mathematical information that is written into words, for example, every minute, এটা কিন্তু একটা this is a mathematical information that you would have to use this thing. It means 60 seconds, but it is written in words. So anytime you come across this kind of thing, always underline them or highlight them so that you do not miss out this thing. Because whenever you'll be trying to solve the problem, if you're in a bit of a hurry, and you will be looking at all the numbers that, okay, these are the numbers that I have. So to solve a certain problem, I need another variable. Where is that? It might as well be given in that word written information. So this is a common practice that you should follow and develop over the years, that anytime you come across a word given mathematical information, always highlight that. Okay, continue. Every minute, water with kinetic energy 14,000 joule emerges from the pipe. The water turns a turbine that is connected to the generator. Half of the kinetic energy of the water is given to the generator. Once again, half is given in word, so underline that as well. Calculate the power input to the generator. So half of the kinetic energy of the water is given to the generator. So how much energy is given to the generator? Every minute, this much energy is coming, emerges from the pipe. So the water is coming out with 14,000 joule of energy, but only half of that energy from every minute is supplied to the generator, which means 7,000 joule.
স্যার তাহলে আউটপুট হবে না 14,000?
No, 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 no. Output 14,000 হবে না, কেন হবে না আমি বলতেছি, হোল্ড আপ। আচ্ছা, আর একটু ছোট করে নিলে মনে হয় ভালো হয়। আচ্ছা না, আমি তো ড্র্যাগ করতে পারবো, সমস্যা নাই। এখানে একটা জিনিস খেয়াল করো, বুঝো, সেটা হচ্ছে you need to read the question and make proper sense of the question. Have a look. আচ্ছা, আমি রেড দিয়ে দেখাই। রেড দেখতে কারো সমস্যা হচ্ছে? কারো? এনিওয়ান? I'm using red so that you can actually very easily figure out that আমি কোন পার্টটাতে লিখছি, ওই জন্য আমি রেড।
জি স্যার, রেড বোঝা যাচ্ছে।
So the question is saying that every minute, so within a duration of 60 seconds, the amount of kinetic energy that the water is bringing out, that is 14,000 joule. Half of that energy is given to the generator. Now you might be wondering why. Well, it's obvious, because all the kinetic energy of the water will not be absorbed by the turbine, because the turbine only has 4 blades. So whenever the turbine rotates by, let's say, about 45 degree, some water jet might not hit the end of the blades. That's one problem. The other problem is that whenever the water will hit the turbine blade, you cannot expect 100% of the water molecules to give all of the kinetic energy and come to rest. I mean, it's not going to work that water hits over here, and after hitting this turbine blade, water simply falls like a drop. There is all possibility that the water is going to splash out. So whenever the water is going to splash out, it means that some kinetic energy is still left within this water. So logically, it's not possible to supply all the kinetic energy into the turbine. That's why they have already given us that expression that half of this incoming energy from the water, sorry, I covered the 14,000, half of the incoming energy from the water, this is given to the generator. So what is the power input to the generator? So input to power input means what? Supplied energy divided by time. Can supply energy হবে কত? 7,000 joule divided by 60 second, and তুমি হিসাব করে যা হয় 3SF আনসার লিখবা। আচ্ছা, এরপর বলছে হচ্ছে such a reason why only some of the kinetic energies of the water is given to the generator. আচ্ছা, এটা তো অলরেডি বলেই ফেললাম, because there are only 4 blades. Some water coming out of the pipe might not hit the turbine blade for certain orientations, and also the water jet that hits the pipe, the water jets that those hit the turbine blades will also have some kinetic energy left as they fall off or as they leave from the turbine. So that much energy cannot be absorbed within the turbine. বুঝে গেছে কি? এইটা এই দুটো এক্সপ্লেনেশন বুঝে গেছে কিনা? আমি এখানে দুটো এক্সপ্লেনেশন বলছি, তোমার যে কোনো একটা লিখলেও হবে, কারণ 1 মার্ক, 2 মার্ক থাকলে দুটো লিখতা, তাহলে তোমার ভালো হতো। এরপর হচ্ছে hydroelectric systems use resources of renewable energy. State what is meant by renewable energy. It's very simple. This is a definition.
স্যার বি নাম্বার হচ্ছে গিয়ে বুঝছি।
আচ্ছা, বি বুঝছো, বি তো বলেন, ওকে ফাইন, বি বাদ। আচ্ছা, তারপর
স্যার 9 নাম্বারটা বুঝান।
Okay, number 9 দেখবো। Number 9 was figure 2.1 shows a motor used to operate a lift or elevator. There is a man in the lift. আচ্ছা, ফিগার 2.1। আচ্ছা, আমি এই ঝামেলাটা না করে আমি এটা জুম ইন করলেই তো এটা বড় হয়ে যায়, তাই না? তাহলে তো আমার কষ্ট করা লাগে না। বিউটিফুল, তো আমার স্পেসও বাঁচে।
স্যার আপনি নতুন বোর্ড ইউজ করা শুরু করেছেন?
নো, ইজ দ্য সেম।
আগে তো পেইন্টে করতেন।
ওই যে আমি রিসেন্টলি মাইক্রোসফট হোয়াইট বোর্ড ইউজ করা শুরু করছি। আই এম স্টিল ফিগারিং দিস আউট লাইক এ চাইল্ডস টয়, এন্ড honestly honestly I'm enjoying the process. I mean, Microsoft Whiteboard seems to provide a lot of flexibility. যেমন এটা আমি চাইলে এখন মোস্টলি,
স্যার
তুই কি জানো এটা ঘুরায় কেমনে? লাইক লক টু ব্যাকগ্রাউন্ড। আচ্ছা, হ্যাঁ, নড়ানো যাবে না, ওকে। আর ও মাই গড।
স্যার
জি বাবা।
স্যার আপনি এটা ঘোরাবেন?
হ্যাঁ, এটা ঘুরাবো কেমনে?
স্যার এটা আবার এখানে পেস্ট করেন তো, এটা ডিলিট করে আবার এখানে পেস্ট করেন, তখন জুম আউট জুম ইনের সময় ঘুরানো যাবে।
ও আচ্ছা,
নিচে নিচে জুম আউট মানে
এটা ধরে।
জি জি স্যার, জি স্যার, এই পড়ে নিয়ে যান। হ্যাঁ হ্যাঁ yes.
থ্যাংক ইউ, থ্যাংক ইউ, থ্যাংক ইউ, লাভ ইউ কিডস। আচ্ছা, আমি জাস্ট প্র্যাকটিস। আচ্ছা ঠিক আছে, আমার কোশ্চেনটা দেখি এখন। থ্যাংক ইউ, থ্যাংক ইউ। তোমরা তো আমার থেকে অনেক ভালো ভালো বুঝছো, তোমরা আমাকে হেল্প করবা। আই রিয়েলি অ্যাপ্রিশিয়েট দ্যাট। Figure 2.1 shows a motor used to operate lift elevator. There is a man in the lift. The input power to the motor is 6200 watts. Define the watt. So that's the definition. And the number B says,
স্যার বিটা বুঝান, বি আর সিটা।
acha, B bojachi. The lift and the man have a total mass of 580 kg. The lift moves up at a distance of 12 meters. Calculate the tension in the cable when the lift is moving at constant speed. Now, here's the deal. If something is moving at constant speed, what is the resultant force? If something is moving at constant speed, what is the resultant force?
0.
Beautiful. Resultant force is
জিরো,
resultant force 0 মানে হচ্ছে upward force equals to downward force.
মানে ইকুয়াল দোনোটা।
Precisely. Then already বলে this lift and the man has a total mass of 580 kg. তো এখান থেকে আমরা ওয়েট বের করতে পারবো, রাইট? তো ওয়েটটা
জি
হচ্ছে
স্যার।
downward force. So since it is moving at constant speed, then downward force and upward force same. So what I can write over here, weight equals to tension equals to 580 into 10. এখানে তুমি 5800 লিখে দিবে।
স্যার ওরা কি ওয়েটকেই টেনশন ধরেছে?
Weight and tension are not the same force, but they are equal because we are trying to solve this for a constant speed scenario.
ও, কনস্ট্যান্ট স্পিড থাকলে তাহলে ওয়েটকে টেনশন ধরে করতে পারবো।
ওয়েটকে টেনশন ধরে করতে পারবো এই কথাটাকে আমি অ্যাপ্রিশিয়েট করতেছি না। আই ডোন্ট ওয়ান্ট ইউ টু লার্ন ফিজিক্স দ্যাট ওয়ে। হোয়াট আই ক্যান টেল ইউ, weight is the force that works vertically downwards for this case, and tension is the force that is pulling upwards. Because there is a constant speed, the magnitude of these two forces are equal. But you cannot say these two forces are equal, because if you say these two forces are same, you would mean that they are equal and in the same direction. But that is not the case. So I would appreciate if you don't use the term that they are same. Rather, you can say their magnitudes are same. I'm cool with that.
তাহলে হয় হচ্ছে এখানে কনস্ট্যান্ট স্পিড যখন, তাহলে ওয়েট যত হবে তাহলে টেনশনও তত হবে।
Magnitude wise,
হ্যাঁ
but not by direction.
হ্যাঁ, বুঝছি স্যার।
Beautiful. এরপর বলছে calculate the increase in the potential energy of the lift and the man. এটা তো খুব সিম্পল। GP delta GP equals to হচ্ছে mg delta h. আমি ডেল্টা দিয়ে লিখলাম কারণ ওরা ইনক্রিজ টার্মটা ইউজ করছে ওই জন্য। তুমি যদি ডেল্টা নাও দাও, শুধু জিপি ইকুয়াল টু এমজিএইচ দিয়ে করো, তাও তুমি ফুল মার্কস পাবা, কোনো সমস্যা নাই। 580 ইন্টু 10 ইন্টু 1 ইন্টু 12 হিসাব করে যা হয় ওই নাম্বারটা লিখবা, জুল লিখবা। ইউনিট না লিখলে মার্কস দিবে না। তারপর হচ্ছে ক্যালকুলেট দ্য এফিসিয়েন্সি অফ দ্য মোটর। আর এফিসিয়েন্সি অফ দ্য মোটর বের করতে হলে যেখানে আমাদের ইনপুট পাওয়ার দেওয়া আছে, এখানে আমরা বের করলাম, কি বের করলাম, জিপি গেইন বের করলাম। তাহলে আমাদের এফিসিয়েন্সি বের করার জন্য আমাদের কি লাগবে? এফিসিয়েন্সি কষ্ট হচ্ছে ইউজফুল
টোটাল
পাওয়ার।
এনার্জি আউটপুট।
হ্যাঁ, তুমি পাওয়ার দিয়ে করতে পারো, এনার্জি দিয়ে করতে পারো। সো আমি যদি এনার্জি দিয়ে করি, লেটস সে ইউজফুল এনার্জি ডিভাইড বাই টোটাল এনার্জি। সো এখানে ইউজফুল এনার্জি হচ্ছে আমাদের এটা কত আসে দেখো তো, ক্যালকুলেটর আমার কাছে ক্যালকুলেটর নাই।
স্যার ইনটু 100% হবে না?
আমি হ্যাঁ ইনটু 100% আমি এখানে লাস্টে দিলেও সমস্যা নাই। এটা কত আসে দেখো একটু বলো তো আমারে। নাকি আমি ক্যালকুলেট করে ফেলবো? আমি তো ক্যালকুলেট করতে পারার কথা। এটা আমি কি আমার পিসিতে ইনস্টল করতে পারবো?
স্যার করতে পারবেন,
চলবে?
চলবে।
পিসিতে
স্যার হ্যাঁ, আপনার পিসি এখানে আসে হচ্ছে গিয়ে যেগুলা পিসিতে চলে সেগুলা পিসির জন্য। আপনার এখানে দেখা যাচ্ছে হচ্ছে গিয়ে পিসির জন্য অ্যাপ্লিকেবল। এই যে আপনি দেখেন দিস অ্যাপ ইজ compatible for all your device, মানে এটা ল্যাপটপে ইউজ করা যাবে।
Okay. এই যে মেলা এই দেখেন তো, don't you want this one? This is a good one, I think. তোমরা না এটা ইউজ করো 991S?
জি স্যার।
ক্রোম ছাড়াটা আমার ডাউনলোড করতে যাবে মানে কত বড় খারাপ।
কিন্তু স্যার
বলো
কম্প্যাটিবল উইথ অল ডিভাইসেস হইলেও স্যার এটা মাঝে মাঝে কিন্তু গুগল ইনস্টল করলে কম্পিউটারে হয় না ইনস্টল, কম্পিউটার চালু হয়।
তাহলে আমার আবার এমুলেটর লাগাইতে হবে তাই না?
হ্যাঁ আমি ট্রাই করিনি অ্যাকচুয়ালি স্যার, দেখি স্যার ইনস্টল করার পর।
আমার মনে হয় এমুলেটর লাগালে মনে হইতে পারে। আচ্ছা 1 মিনিট পর আমি পজ দিয়া এই প্রবলেমটা to start the recording after solving the calculator problem partially. Writing a number like this is not really a good idea. So what I do recommend that you always, whenever you come across this kind of a large number, always prefer to write the answer in scientific form or standard form. So this is going to look like this. And we're going to write 69.6 into 10 to the power 3 joule. So this is the format that you should practice and learn and adopt to use for long numbers or that kind of stuff. So this is the energy that we have over here, and whenever we calculate efficiency, we have to do energy by energy or power by power. So if I'm going to use the term energy by energy, this is going to be 6 point. ভুল লিখলাম না এখানে? আচ্ছা আমি ঠিকই লিখছি অ্যাকচুয়ালি, এটা অ্যাকচুয়ালি ভুল, লেখাটা ভুল হয়েছে। লেখাটা ভুল হয়েছে মানে হচ্ছে সায়েন্টিফিক ফরম্যাটে লেখার সিস্টেমটা হচ্ছে something point something something to 10 to the power something. So this number should have only one digit before the decimal point. So this should be written in this format. 6.96 into 10 to the power 4. So this is the useful energy that we actually could obtain for the process. So we can place that over here, 6.96 into 10 to the power 4. And we have to calculate how much energy was delivered to this whole system within the given time. The question already given us the time. It says that the whole process happened for a duration of 15 seconds, and the input power was 6200. So if you do the multiplication of power into time, 6200 into 15, you get the total input energy. And you can calculate this out, and eventually, obviously, you can multiply by 100%. 100% because I only wrote the equation over here. But you can write this much, and whatever the calculator value that you get, you can directly put it as percentage over here. So which I'm gonna do this much divided by bracket 6200 into 15 bracket close. Bracket close হলো না কেন? Okay. So we got that value. So we're gonna multiply by 100%. So I'm just gonna multiply by 100 to get the number. So the efficiency would be 74.88. 74.8. বুঝা গেছে কিনা?
জি স্যার বুঝছি।
আচ্ছা পরেরটা দেখি, সি নাম্বারটা দেখি আমরা। সিতে বলছে হচ্ছে, আচ্ছা সি তো নাই, এটুকুই। আচ্ছা আরেকটা কোনটা বলছিলাম? এই পেপারে আর কার কোনো প্রবলেম আছে?
স্যার 30 নাম্বার, এটাই লাস্ট প্রবলেম।
সমস্যা নাই। এটা
13
by 6. This is actually a good problem. State the principle of conservation of energy. এটা তো basic idea লিখবা that total energy of a system remains conserved, or energy cannot be created or destroyed. It can be only converted from one form to another form. Figure 3.1 shows a miner using a head torch powered by a battery pack. The battery pack contains cells that power the filament lamp in the head torch. So there's a battery pack in the back. This is the wire. Head torch is running. Still, the main energy changes that take place in the cell. Now the question is still the main energy change that takes place in the cells. Cell. Not the whole thing.
স্যার কেমিক্যাল এনার্জি থেকে না?
Chemical to electrical. That's it.
দুইটা লিখলে হবে, এখানে 2 মার্ক তো স্যার।
So chemical is 1 mark, electrical is 1 mark.
ও এখানে কেমিক্যাল আর ইলেকট্রিক্যাল 2 মার্ক।
তুমি এর থেকে বেশি আর কি লিখতে পারো বলো তো? আর কিছু কি লেখা পসিবল?
স্যার লাইট লেখা লাগবে না?
কোশ্চেন পড়ো। কোশ্চেনের লাস্টের ওয়ার্ডটা কয়েকবার পড়ো।
বুঝছি স্যার।
আচ্ছা ঠিক আছে। এটা বলছে যে two different form of energy that are produced in the filament lamp, light, heat. দুইটা ওয়ার্ড লিখবা, আর কিছু না, 2 মার্ক। সি নাম্বারটা হচ্ছে ইন্টারেস্টিং কোশ্চেন। লেটস হ্যাভ লুক এট সি। সি তে বলছে an identical battery pack, সেটাকে আমি বের করে নেই কারণ এটা আমি কাজ করব। ওকে। An identical battery pack powers a different head torch that uses light emitting diodes, LEDs, instead of a filament lamp. The two torches are equally bright. Important term, they are equally bright. এটা আমাদের কাজে লাগবে। But the efficiency of the torch using the LED is much higher. State how the amounts of different forms of energy produced in the LEDs compare with the amounts produced in the filament lamp. Let me explain this whole thing in my in my way, and then we can precisely answer this question. What you have to understand that both of the torches are equally bright, which means filament lamp and also LED lamp. LED lamp can be shown like this. This is the symbol, circle symbol for LEDs. They both are equally bright, which means they produce equal amount of light energy. Eta light equal. Eta দিয়ে আমি equals to mean করতেছি, vertical equals to, which is a sign I just made up. Don't use it ever. So filament lamp and LED light, they will both going to produce exactly equal amount of light energy. But the efficiency of the torch using the LED is much higher. Now, how can we use this information? Efficiency of the light of the torch using the LED is much higher. Now, efficiency বেশি হওয়ার মানে হচ্ছে এইটার এই LED লাইটের absorbed energy কম. So light divided by chemical energy, because that's the battery's fed energy, for the LED is greater than the light divided by chemical energy multiplied by for the filament lamp. এই জিনিস কি বুঝতেছো? এই কোশ্চেন তোমাদের কখনো লেখা লাগবে না, বাট এই আইডিয়াটা কি বুঝতেছো যে এইটা হচ্ছে এইটা এটার থেকে বড়, এটা বুঝতেছো?
স্যার তাহলে কি এটা ফিলামেন্ট ল্যাম্পে কেমিক্যাল এনার্জি যত ওইটার চেয়ে লাইট কম দেয়, আর এলইডি লাইটে কেমিক্যাল এনার্জি যত ওইটার চেয়ে বেশি লাইট দেয়?
না, দুইটাই equal amount of light produce করে. So the light produced for both of them are equal, which means you can cross out the light over here. আচ্ছা, তোমাকে ম্যাথসে ইনইকুয়ালিটি পড়ছো? ইনইকুয়ালিটি কিভাবে কাজ করে ম্যাথসে up so far?
জি স্যার।
So
জি স্যার।
you do know that if 1 by x is greater than 1 by y, x is less than y, এটা জানো?
জি স্যার।
তার মানে হচ্ছে যেহেতু লাইট এনার্জি দুটোরই ইকুয়াল, সো লাইট এনার্জি দুটোকে আমি both sides cross out করে, and if I reverse this equation, which means chemical energy consumption in the LED lamp is less than the chemical energy consumption in the filament lamp. So LED lamp কম chemical energy খাবে, আর হচ্ছে filament lamp বেশি chemical energy খাবে. So আমি যদি একটু ভিজুয়ালি যদি একটু এঁকে দেখাই, let's say this is the amount of light. Let me use a rectangle. Let's say this is the amount of light that both of these bulbs produce. Wow. Which comes from, for the filament lamp, the consumed energy is, let's say, I'm going to draw it green. Let's say the consumed energy is this much. How many boxes are here? 1, 2, 3, 4. For the filament lamp, let's say the consumed energy is this much, which means we're going to have some heat energy of 1 box. এটা কি বুঝতেছো? This is for the filament lamp. As for the LED lamp, they both produce the same amount of light, but the LED lamp consumes less amount of chemical energy, which means, let's say, it consumes this much input energy. I'm giving a bit less compared to that one, slightly less. Which means this one is producing this, I mean, out of this 3.5 box, it is producing 3 boxes as light energy. Essentially means that waste would be how much? Half box. এই যে আইডিয়াটা কি বোঝা যাচ্ছে?
Ji, sir.
Everyone else, দেখো
জি স্যার বুঝছি।
তাহলে এইটা ইউজ করে আমরা এই আনসারটা কিভাবে দিতে পারবো? কোশ্চেনের মধ্যে বলছিল state how the amounts of the different forms of energy produced in the LEDs compared with the amounts of produced in the filament lamp. 2 mark. So we're going to write 2 sentences. We're going to write, and they have only asked us state. They haven't asked us state and explain. So we're not going to go for the explanation. If I was writing this answer, I would write this much. Both LED and filament lamp produces equal amount of light energy. Full stop. LED produces less heat energy than the filament lamp.
জি স্যার।
Or we could have written filament lamp produces more heat energy than LED lamp. দুটো যেমন লিখলে হবে, both are okay. But দুটো লেখার দরকার নেই, দুই সেন্টেন্স লিখবা। লাইট এনার্জি দুটোই ইকুয়াল, আর ফিলামেন্টের হিট এনার্জি প্রডিউস বেশি।
জি স্যার বুঝছি।
ওকে, আচ্ছা, এখানে আর কোনো প্রবলেম আর কারো?
না স্যার।
আচ্ছা, যারা এখনো ওয়ার্কশিট করো নাই, প্লিজ ওয়ার্কশিট করো। ক্লাস টেস্টের আগে যাতে ওয়ার্কশিট করা শেষ হয়। আর ওয়ার্কশিট করা হলে ওয়ার্কশিট প্রবলেম আমি অন্য কোনো সময় তোমাদের সলভ করার জন্য হেল্প করতে পারবো, সমস্যা নেই। আচ্ছা, this is 7.07. I'm going to start the lecture of density pressure in today's class. আজকে শুরু করতেছি because we have enough time, which is the last chapter for this worksheet, and then we're going to receive the second booklet, which is the heat booklet. আচ্ছা, তোমাদের সাথে আগে আলাপ করছিলাম যে এটা পরে কোনটা শুরু করলে তোমাদের ভালো হয়। যারা এখনো স্কুল করতেছো, তোমাদের জন্য কোনটা শুরু করলে ভালো হয়? You can pick any of the topic like electricity, magnetism, atomic physics.
স্যার আপনি থার্মাল শুরু করতে পারেন।
Okay, thermal is one recommendation. Anyone else have any other recommendation that helps you to go along with your school? Okay, we have 3 people talking about thermal, and any other?
স্যার আপনি হয় গিয়ে যে সিরিয়ালেই চলে যান।
সিরিয়ালে চলে যেতে আমার সমস্যা নাই, কিন্তু জিনিসটা হচ্ছে যে আমিও পার্সোনালি সিরিয়ালে যাওয়ার পক্ষপাতী। কেন আমি এই কথাটা বললাম সেটা হচ্ছে যে তোমাদের অনেকে স্কুলের পরীক্ষা চলতেছে। এখন যদি আমি স্কুলের সাথে রিলেভেন্ট একটা চ্যাপ্টার পড়াই, তাহলে সেটা হচ্ছে তোমাদের কষ্ট করে 2 বার পড়া লাগবে না। আমার এখানে জিনিসটা বুঝলাম, ওয়ার্কশিটগুলো করলা, স্কুলের পড়াটা হয়ে গেল, ভালো মার্কস পাইলা, তোমরাও খুশি, প্যারেন্টসও খুশি, আমিও খুশি, সবাই খুশি।
স্যার তাহলে তো সব স্কুলে মনে হয় এখন থার্মাল পড়াচ্ছে।
ওই জন্য জিজ্ঞেস করলাম যে কোনটা শুরু করলে ভালো হয়। থার্মাল পড়লে মনে করো থার্মাল পড়ায় শেষ করতে আমাদের অ্যাবাউট ধরো 1.5 থেকে 2 মাস সময় লাগবে। তারপর আমরা পরের টপিক শুরু করতে পারবো। এর মধ্যে তোমাদের পরীক্ষা হইতে থাকবে।
স্যার আমাদের স্কুলে থার্মাল শেষ।
আচ্ছা,
স্যার আমাদের স্কুলেও।
তাহলে তোমরা সবাই থার্মাল পারো, তাহলে কিছু পরীক্ষা দিয়ে দিই, তাই না?
স্যার একটু কাঁচা।
স্যার আপনি বুঝিয়ে দিলে হয়।
আচ্ছা, I was just kidding. আচ্ছা, আমি তোমাদের ডেনসিটি প্রেসার পড়ানো শুরু করব। তোমরা একটু কষ্ট করো, সেটা হচ্ছে ডেনসিটি প্রেসারের নোটটা বের করো। ডেনসিটি প্রেসারের নোটটা বের করে এখান থেকে একটু পড়া শুরু করো। আমি একটু ব্রেক নিব, আমার পিচ্চিটা একটু দেখতে যাবো, সে একটু ক্যামেরা করতেছে। I'll take a break of 5 minutes and I'll resume at 7:15. আমরা ডেনসিটি প্রেসার আমরা 15 মিনিট পড়বো, ঠিক আছে? তোমরা একটু নোটটা বের করে একটু এই 5 মিনিট একটু পড়ো। Or if you want to take a washroom break or anything, you can also take a break with me, no big deal. 5 minutes. We resume the recording. Let's go to density pressure. আচ্ছা, তোমাদেরকে আরেকটা হেডস আপ দিয়ে রাখি, তোমাদের পরের চ্যাপ্টার নোটস গুলো এত বেশি গুছানো নাই। This is the copy from Sharita, who is extremely awesome to have notes of this level. পরেগুলো আর একটু স্ক্যাটার্ড। আমি এগুলো টাইপ করার চেষ্টা করতেছি, কিছু কিছু করছি, বাট দে আর অল স্ক্যাটার্ড অ্যাজ ওয়েল। সো ক্লাসেসগুলো এত লুক্রেটিভ বা এত ভালো না হওয়ার সম্ভাবনা আছে। But I'll help you understand the whole thing. So, density pressure chapter first, the first thing that we have, experiment to measure the density of এটা C হবে না, এটা A হবে, এটা একটু কাট করো, this is going to be A, of a non-uniform object. Now we discussed the experiment first, but where is the definition of the density pressure? Okay, I think this kid means the first definition of the density, which is actually really simple. I'm going to write this down for you. You don't have to write this, or if you want, you can write this up in the upper page. You can write over here the definition of the density, or I can recommend everyone writes this. It's pretty simple. Density of an object is given by the symbol rho. The rho looks like P, but it's not essentially P. Let me show you the type form for rho. Many of you might have seen this in your books. I'm doing this because I can. The rho looks like this. This is the small rho. So it's a one stroke P. So starts from the bottom and goes up, or you can write it like an S. So that's the type form. Sometimes handwritten rows can look like this with a little bit of curve at the bottom, or this kind of version is also possible with a little bit of curve at the bottom. That's also okay. So density of an object is given, which is represented by the Greek letter rho, is given by the mass of the object divided by volume. The SI unit for density is kg per meter cube, but in some cases you can also have density expressed in gram per centimeter cube as well. So this is also sometimes this unit is also given in the question just to bother the students so that they have to undergo the unit conversion, which is not that difficult, but let me just show you how this is to be done. If you want to convert gram per centimeter cube into kg per meter cube, this is how it's done. So I'm going to write 1 gram and 1 centimeter cube right over here. 1 gram means 1 by 1000 kg, because that 1 gram is 1 by 1000 parts of 1 kilogram. And 1 centimeter cube, I'm not going to do the whole cube thing. So 1 centimeter, only 1 centimeter is 1/100th of a meter. So I'm going to write 1 by 100 meter. I'm going to give a whole cube over here so that you understand the concept. এই কনভার্সনটা কি বোঝা যাচ্ছে কি লিখছি এখানে? 1 gram converted to 1 by 1000 kg and 1 centimeter converted to 1 by 100 meter. এটা কি বোঝা যাচ্ছে?
Yes, sir.
আচ্ছা, এটা তাহলে আমরা হিসাব করে ফেলি এখন কত আসে। এটা আসবে হচ্ছে 1 by 1000 into একের পরে 6টা শূন্য 1 2 3 4 5 6 divided by 1 kg per meter cube. So এখান থেকে যদি আমরা ক্রস আউট করি 1 2 3 1 2 3, so ultimately we are getting 1000 kg per meter cube. Sweet information. 1000 kg per meter cube is the density of pure water at 4 degrees Celsius, which is the densest condition of water, which is quite interesting because water is such a material which is widely available in nature on Earth's surface. But the interesting thing about water is that if we start to cool down water from room temperature, let's say we have some water within a beaker that is at room temperature, let's say 25 degrees Celsius. Let's say that at this point the water is at this level. If we start to lower the temperature, the volume of the water is going to start becoming smaller. For a large beaker, this might be very difficult to observe. So to make this observation easier, what we can also do, we can take a flask, which has a shape like this maybe. And this flask can have a cork over here, and we can insert a small tube through that cork and then fill up this whole thing with water. All the inside, the whole thing is filled up with water, and it is also filled up by a certain height of this small tube. The reason we are appreciating a small tube because here a little bit of volume change will give us a much more visible height change. The idea is that, I mean, you have a very large cross-section area for a beaker, like it's a really wide space. So if you have a small volume decrease, you are not going to see much to height drop because that will be very small. But if you have a much smaller cross-sectional area for a very small volume decrease, you will still have significantly visible height drop. So we can use a setup like this. Flasks don't come in this shape. This is just a hand-drawn flask shape, so disregard my poor drawing skills. What we're going to see that if we start to cool this thing from 25 degrees Celsius, we're going to see this level going down, 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 up till the temperature reaches 4 degrees Celsius. At 4 degrees Celsius, it is going to come to a certain level. Let me show that level with red maybe. So let's say at 4 degrees Celsius, it comes to this level. Then if we start to cool it even further, we're going to see that the water level is going to start rise again. And if we make this whole thing into ice, and if we somehow, by some magical manner, if we can also allow the ice to have increased to this tube, we're also going to see that when ice, this whole thing becomes ice at 0 degrees Celsius. At 0 degrees Celsius, we're going to have a state change. So it's going to take some significant amount of time for this whole thing to become ice. It's called latent heat of freezing in this case, or latent heat of solidification. We're going to learn detailed about these terms in our heat chapter, or maybe you already know. But if we allow the ice to go further down, let's say -1 degree Celsius, -2 degrees Celsius, we're going to see that this whole chunk is also expanding in volume. That happens. So water has the smallest volume. Any amount of water or any mass of water has the smallest possible volume at 4 degrees Celsius exactly. And Pure water at 4 degrees Celsius happens to have a density of 1000 kg per meter cube. This is very important information, and we're going to need this information for our mathematical purposes a lot. And you have to remember this information. The sheet, the formula sheet of your, do you get a formula sheet? Do you guys get a formula sheet for your OLS exam? LSP will get a formula sheet. I forgot. Let me just check. If we can go to any year and check out one. So let's say 1. No, you don't get any formula sheet. So you just have to remember that water has a density of 1000 kg per meter cube. Whenever we use this term that water has a density of 1000 kg per meter cube, in many cases we do not essentially state that it was measured at 4 degrees Celsius. But you should know by heart that 1000 kg per meter cube density of water is exclusively available for pure water at 4 degrees Celsius. And that's that. If you have impurities, it is going to be different, more or less. I cannot specifically tell you because different type of impurities can affect it differently. And if you have any temperature other than 4 degrees Celsius, it is definitely going to be bigger. So even whether you heat it up or whether you cool it down, the volume of the water goes higher. So at the 4 degrees Celsius, water has a density of 1 gram per cm cube, or it can be also written as 1000 kg per meter cube. Both of these values are helpful for us, so we're going to use this thing over time. Another information that I'd like to talk about the unit is that sometimes centimeter cube can also be written as cc. cc is also a used term, prochulito term, but not SI unit. cc stands for cubic centimeter. Cubic centimeter. So that basically means centimeter cube. So this is in actual unit fraction. This is just a acronym for cubic centimeter. So cc is also the same thing, which means 1 gram per cc also means 1 gram per centimeter cube and 1000 kg per meter cube. So you should also know that cc means what? Cc means centimeter cube, cubic centimeter. So that's the definition for for density. And then comes the experiment. That if we are trying to measure the volume of a regularly shaped object, volume measure kora onek shohoj. Now if you wonder what do we mean by regularly shaped object? Regularly shaped object means objects where you can measure multiple dimensions, multiple linear dimensions of the object and eventually calculate the volume. For example, a cuboid is a regularly shaped object. You can measure the length, breadth, and height, and then if you multiply, you get the volume. That's a regularly shaped object. A cube is a regularly shaped object. You can only measure one side because cube pretty much have the same dimension in all directions. You measure one side, and if you cube it, you should get the value. Although one thing you should always remember that whenever we do experiments, whenever we actually do physical experiments, it is always recommended that we measure a certain number or a certain quantity multiple times and take the average of that value for further calculation. Taking multiple readings of the same thing and averaging it actually gives us more reliable results. So if you wonder how are you going to measure the multiple dimensions for a cube, that is actually pretty simple. Let me just show you by a bit of an drawing. Okay, let's just take this whole thing up. It's over here. So the idea is that if we have a cube object that looks like this, 1 2 3 4 1 2 3 4 1 2 3 4 and 1 2 3 4. Oh, awesome. And is it possible to copy paste this thing other than drawing the whole thing once again? Copy paste. Wow. Okay. Why did I copy paste it? Now we can take it up over here. Let's say I'm going to place it right here. So let's say this is the view of a cuboid object. Just to make good sense with you, I'm going to make it a bit dotted line over here. Oh, I cannot erase this. Never mind. So let's say this is a cube which is visible from all the sides. So here are the sides of the cube. And measuring multiple sides would mean that we can first measure on this corner, then we can measure on this corner, then maybe we can measure on this corner and this corner, opposite sides, and then we can also measure this corner and this corner. So we can take 2 readings from all the faces and we can average it out to get a good reading for this thing. And if you have a cuboid, for example, let's say if I go ahead and draw a cuboid, let's say a bit longer length. And Let's place it up over here, maybe. Or maybe here is a better idea because we're going for the cuboid. And then if we fill up the whole cuboid thing, let's see, these are the edges of the cuboid. It looks a bit weird, but try to visualize. I mean, once you see the three-dimensional shape, you are not gonna miss it. But getting the three-dimensional shape first time can be a slight challenge. So if you have a cuboid, it is if you're trying to go for multiple measurement, it is recommended that you measure the same dimension multiple sets. For example, over here, let me label those dimensions. This is our length, this is our breadth, or you can also mean width. You can represent this by W as well. And let's say this is height. So the length can be measured, let's say, by measuring over here once and maybe over here once. We can also measure the length maybe on this side and on this side. Sorry, these are not lengths. We can measure the length, let's say, on this side. We can also measure the length on we can measure the length on this side. Kilo. So we can measure the length through this side, and we can also measure it from this side. We can also we can measure the length from multiple different orientation. That's the whole point, and eventually we can average it to get the average point. You get the information, and then we can have a sphere. A sphere only has diameter, so you can measure the diameter. Sphere volume formula hoche 4/3 pi r cube, or if I write this in terms of diameter, is going to be 4/3 pi into d/2 whole cube. That can be given as 4/3 into pi into d cube by 6. No, 6 not 8. So we're gonna get 1/6 pi d cube. So in terms of diameter is 1/6 pi d cube. In terms of radius, it is 4/3 pi r cube. So you can use either of this information over here. But one thing you should always understand: for any solid sphere, r cannot be a measured quantity. D is a measured quantity. A measured quantity is something that you can measure and get the value out of an equipment, out of an instrument. Whereas r, the radius of a sphere, can be only be obtained by dividing the diameter by 2. So r is always calculated, whereas d is the measured one. There's a big difference of these two things, which will be much more significant whenever you get it up to your A levels. So just I'm don't I mean, you should be careful to consider what is measured and what is calculated. For example, in this case, all of the linear dimensions can be measured, but the volume is calculated. So this is applicable for regularly shaped objects, where you can measure multiple linear dimensions and eventually convert that whole thing into volume. As for non-uniform objects, the only way we can measure it is by using a measuring cylinder. So you fill up a measuring cylinder up to a certain level, take the first reading, drop the object carefully into the water so that no water gets splashed out, or the object does not or the water level doesn't spill out. So you carefully drop the object in the water, the object goes down, and eventually the level of the water goes up a little bit, and then you separate those two values to get the volume of the object. This is applicable for objects which are heavier than water, which are going to sink in the water. If an object does not sink in the water, there are two different ways we can actually go for. Let's say an object does not sink in the water. Let's say a piece of plastic. You want to measure the volume of plastic using water and measuring cylinder. How to do that? The logical way to achieve this, there are two different ways we can achieve this. There is an easier way, there is a harder way. The easier way is that we can have the cylinder over here. Let's say we fill it up with water up to this much level, and then we take this reading, we know this reading, and then we can put the object inside the water surface, but we'll see this is floating. So we can actually use some sharp needle kind of object because the volume of a needle is actually very small. So you can use 2 or 3 needle type of or pointy objects to push this object down so that it actually goes under the water, and then take the measurement once again. Now, one problem for this method is that some part of the needle will also be underwater, so there can be slight error in the second reading. The water level is going to be rise a little bit, but we can consider that error to be negligible. That's why I'm talking about pushing it by a very small tiny head object so that the volume measurement is not so wrong. It can be slightly wrong, but it's okay. That's one way to go for it. The other way we can go for is by using a sinker. Now, what does the sinker mechanism looks like? Let me show you. So let's say we have a measuring cylinder. Let me draw a good measuring cylinder because we're going to be needing a lot of measuring cylinders over here. So let's say this is a measuring cylinder. Can I select the whole thing? Yes. No. Why can't I select the whole thing? Well, এটা দিয়ে আমি সিলেক্ট করতে পারতেছি না কেন? আরে মা, আচ্ছা বাদ দাও। মনে করো if we have an object, we are trying to measure the volume of an object that floats on the water. This is the last thing we're going to discuss in today's class. We are over time. Is that first you measure, let's say you fill up the beaker by a measuring cylinder by a certain height of water and take that reading. Let's say this is our reading number 1, reading 1, or I can write height 1 because this is the height of the measuring cylinder, or I can write volume 1, v1. Okay, then we're gonna only put the sinker. So this is 1 2 3 4 5 2 3 4 5. So we're gonna submerge the sinker within this thing. So let's say after putting the sinker, so which is gonna sink over here. This can be a piece of metal, piece of heavy rock, which is definitely gonna sink over here. We're gonna put this sinker over here, and we're gonna measure a second reading. So the difference between these two readings, v2 minus v1, gives you the volume of the sinker. এটুকু মনে রাখো. Then we're gonna do, we're gonna paste হচ্ছে না. এটা কাজ করে না কেন? Okay, কাজ করছে. So then we're going to so let me just delete this one or erase this one. Erase this one. Acha, এই লাইনটা এখানে থাকুক. Let me use a different color because we are running out of time. What we're going to do next is that we're going to tie up the light object. Let's say that is the red thing is the light object, which tends to float on water, and the sinker together with some thin strings. We're going to tie these two up, and then we're going to take this whole thing and we're going to put it in the measuring cylinder. And in that case, the level of the water is going to rise up by a bit more height. Let's say currently this level is v3. So within this v3 volume, we have both the sinker and the object. So if we do the subtraction of v3 minus v2, we can get the volume of the object. Because what is the difference between these two readings? বলুন, বুঝতেছো কি বলতেছে?
জি স্যার।
So the difference between these two things is that there was an additional object over here which gave us a bit more volume rise. So if we do the subtraction over here, now you might wonder, তাহলে আমি এটা কেন করলাম, আমি এই জিনিসটা কেন করলাম, আমার এই v1 টা বের করার দরকার কি ছিল? v1 টা মাঝে মাঝে বের করে দরকার হয় for certain mathematical calculation, but if you're only trying to find out the volume of the light object, to be honest, এই রিডিংটা তোমার না নিলেও হবে. You just take any random amount of water, sink the sinker down, take the v2, take this reading and only take this reading, and the value of this reading can basically give you the volume of the object which tends to float on the water, lighter objects than water.
এই পর্যন্ত আজকে ক্লাসের জন্য থাক, ইনশাআল্লাহ নেক্সট ক্লাসে আমরা ফার্দার পিক আপ করবো। আর তোমরা যারা ওয়ার্ক ইঞ্জি করো নাই, প্লিজ করো, কোনো প্রবলেম থাকলে আমাকে দেখাও। থ্যাংক ইউ ভেরি মাচ, আল্লাহ হাফেজ।